This is a part 1 of 2 parts video, and in this lesson, you will be able to learn about exponential growth and decay. So I want to first explain the definition of exponential function so that you can be able to identify exponential decay or growth from table or from graph. And I'll explain the equations of exponential growth and exponential decay. So when you have an exponential function, so you are talking about a function with a common ratio or a common multiplier. So when you have a common ratio or a common multiplier, that means like you are given this value in this table. When we divide the subsequent term in the table by the previous term, in this case, we have 2 divided by 1, so we have 2. So, and you can see that the table is chronologically increasing. That is, it's just like 0, 1, 2, 3. Okay, so they are not jumping any values. So in this case, 4 divided by 2 will be 2, and 8 divided by 4 will be 2. So when you have this all two that are the same value, so we call that a common ratio or a common multiplier. In this case, our common ratio and common multiplier is greater than 1. So when you have this situation that a common ratio is greater than 1, we are talking about exponential growth. So if we plot the values in this table, we are going to get something like this. Okay, we are going to get something like this, and we can join those points together to get an exponential growth. And as you can see, this function is consistently increasing. So in the case of exponential decay, again, if we do the same thing by dividing, okay, so here we have 1 over 2. Okay, if we divide 1 over 4 by 1 over 2, we are going to end up having 1 over 2 again. If you divide 1 over 8 by 1 over 4, you're going to have 1 over 2. So you can see that we also have a consistent common ratio that is the same down the table. So you have, okay, you have the same common ratio. But in this case, our common ratio is greater than 0 but less than 1. So when we have this situation where the common ratio is between 0 and 1, okay, then we have an exponential decay. So if you graph it, you will see that the value is consistently decreasing along the graph. So for exponential function, we can represent it by this f of x equals to a b raised to the power of x, where a will be the initial value in this case, that is your starting point, and where the b will be the ratio, the base, the multiplier. So yeah, leave it to the math. B has a lot of names. So it's a ratio, is the base, or is the multiplier. So please just don't be confused. Just learn the format. If f of x equals to a, b raised to the power of x, that tells you that that b is a ratio, the base, or the multiplier. So in many situations, you are not going to be given the multiplier in the questions. So you are instead going to be given like a growth percentage or a growth rate. So now, we can now represent those type of situation by writing our f of x in another format where a is still the same, okay, a is still the initial value, but now instead of writing b, we will write 1 plus r to represent the exponential growth. That is, the exponential growth is going to be greater than 1. So r in this case will be the growth rate that you are given in the question. So in the same vein, when you have the exponential decay, you can write it as f of x equals to a multiplied by 1 minus r. So this is still the value of the b in the first equation, okay? That is still comparable to b in the first equation. So, but in this case, our b is 1 minus r, where this r is now the decay rate. Okay, so you are given this exponential growth and exponential decay. B, the multiplier, can either be 1 plus r or 1 minus r, depending on when you have, if that you have a growth or a decay. Thank you.